Look at this table. This shows the effect of gender, independent variable, on Hillary Clinton feeling thermometer ratings. That's the dependent variable. Controlling for marital status. So in this panel we have all unmarried respondents, males and females, and down here we have married males and females. The gender gap, first consider the mean differences in the Hillary Clinton feeling thermometer among unmarried respondents. 57.64 is what unmarried males rate her on average, and that goes up about 9 points among unmarried women. So there is a large, noticeable gender gap among unmarried respondents. There's also a gender gap among married respondents, but it's much weaker. I guess you'd say 53.69 among married males. In fact, that's the lowest mean of all the groups here, 53.69. And it goes up. There is an increase among married females to 58.18, but that's only about a 4-point gap. So if someone were to ask, what's the gender gap, you would have to say it depends. It depends on whether people are unmarried, in which case it's about 9 points, or married, in which case it's only about 4 points. Of course, something that goes along with interaction on the independent variables, if you look at the effect of the control variable, marital status, among males, so we're going to compare males who are unmarried to those who are married, the gap here, I guess you call it the marriage gap, is only about 4 points. Married males are only about 4 points cooler toward Hillary Clinton than are unmarried males. For females then, accordingly, the marriage gap is about 9 points. It drops from 66.82 all the way down to 58.18. Indeed, married females at about 58 are almost the same in terms of how they rate Hillary Clinton as are unmarried males, who are also about 58 degrees. Here's the relationship in graphic form. I created a line graph here, multiple line chart. Here's the independent variable along the horizontal, male to female, and you can see here this line, the unmarried line, has a much steeper slope than does the married line. And again, you see that interesting parallel. Married females right here only slightly warmer toward Hillary Clinton than unmarried males. So you see both effects in action here. The marriage gap between the lines, and then the gender gap along the lines. So the effect of the female dummy is either weaker or stronger depending on marital status. Let's figure out a regression model that will capture this, this varying effect of female, which is conditioned on marital status. This model, Hillary Clinton rating equals A plus B1 female, that captures the female dummy, the base effect, plus B2 married, that captures the base effect of marital status, plus B3 married times female. That permits the coefficient on female to take on added punch, if you will, when both married and female are switched to 1. So we have variables for female. We created that earlier in this chapter, and married. We created that back in chapter 3. We have to create an interaction variable, an interaction term to enter into the model that we can estimate with the coefficient B3. We do that in compute. Although there is a wrinkle in the way SPSS handles zero values. Transform, compute. You can see here I've already created it. I'm calling the interaction variable married underscore female because it takes on the value of 1 for married females. And essentially you just multiply the two terms together, married times female. Since both of these are 0 1s, a married female will assume the value of 0 for all respondents except for married females. Here is the wrinkle. Go down and click if. You get this window opening. When you open it, it says include all cases. Click the radio button next to include if case satisfies a condition. And you must type not missing female and not missing married. There's a quirk in the SPSS compute statement, which you can read about in the book, but this makes up for that quirk and makes sure that you're only going to have valid cases when you compute the interaction variable. It's going to ask me if I want to change my existing variable. It will not ask you that. All right, now we have the interaction variable. Let's just run the regression. Analyze, regression, linear. I've already set it up. Here's the feeling thermometer, Hillary Clinton. I'll give you a second to find that, FT_H Clinton. There's female dummy. Give you a minute to find that, a second to find that. There's the married dummy, created that back in chapter 3. And here's married female, the variable that we just created with the compute statement. I'm going to click OK. Here we have it. Constant is 57.64. This is the average Hillary Clinton feeling thermometer rating among unmarried males. Why is that? Because unmarried males have zeros on both the female dummy and the married dummy. Look at the effect of married here, minus 3.947. That is the mean difference between unmarried males and married males. We already saw that married males had the lowest rating of Hillary Clinton on average, and it was about 4 points, if I recall correctly. So that coefficient depresses the Hillary Clinton feeling thermometer rating among males. That's the marriage effect among males. Look at the size on this female dummy. That's 9.175. That's about 9 points. What is that? That is the mean difference between unmarried males and unmarried females. We already saw that, and the mean comparison was about 9 points, and there it is. Now what about married females? Married females are reduced by 3.947 points. That's the marriage effect. And then they're reduced by 4.688 points. That's the married female interaction effect. So just to be clear, married females get all these coefficients. They get the 57.640. Because of the female effect, they get 9.175. But that is reduced by the interactions of marriage, which is the base effect of minus 3.947, and 4.688 for married females. Over here, we look at the T ratios and the sig values. All of these coefficients are statistically significant, so we've modeled the interaction effect and the base effects of the variables. They have all turned out to be statistically significant beyond the 0.05.